Oh, I need to set up my iPad. Oops. Need to have a live view of the tablet stuff. Let's get this up first. While Windows takes a minute to load a 30-year-old program. And then, let's see, I think it was Zig current. Run. Okay, so tonight I want to start animating these tiles, get stuff moving. The animations will be very easy since we're just working in 2D. Everything is a square. It's basically the programming version of the physicist's sphere. Yeah, so currently, what did we do last time? We got, we linked up the tiles, or we drew the tiles, we linked up input, got this working. I can probably turn off all of this debug output, to be fair. Debug, print, grid, let's just turn this on. But yeah, so I want to just actually get these tiles moving. So we need to come up with the most simplest animation system we can. One of my huge pet peeves with animation is when when an animation is playing, it like locks the input. Like, that's infuriating. It's something where this happens in so many games. You like move a character and then you like hit another button to move them, but the game says, no, I'm ignoring your second input because the character hasn't moved to the first. I think I ranted about this when we like animated the cube. We'll do a similar thing here. All of this to say, if like an animation is only a third of the way through and then you like decide to select another tile, it's going to just immediately snap the tile and begin the next animation. It's not going to like pause your input. The game isn't going to like force you to go at its pace. You go at your own pace and the game then catches up. So, so yeah, how should we begin this animation? So I think if we had an enum that just tracks whether an animation is playing or not, or so the way I'm thinking of doing it is that each animation is going to like offset the moving tile from its final position. So we're going to need to know what tile is animating. I guess the direction it's animating in, and the rest of the stuff, like the rate of it. So what's like the simplest data structure we could use to hold this? For the tile that's animating, we could just, if we just like set it to be 0, can just denote that nothing's animating, because it's not as if the empty tile is ever animating. Otherwise, that denotes something's animating, and then we can just have another enum for the direction that is describing what direction things are. We already have a direction, a grid movement direction though. So we can simply, when we when we move something in the grid, we can simply like save this in this animation state, and then we offset this way. Okay. So let's do after timing animation. We can say animating tile, and we just want this to be a byte, and it will be 0 to begin with. You're low on disk space. Storage sense is freeing up space on your PC. Why? Are we really running out of space? How much space are we running out of? Oh, wait, 1 gigabyte free? That's not good. Okay, we're gonna have to delete some stuff. That's really not good. Okay, this is already uploaded to YouTube. We can delete that. Why is there so little space? Like, what's taking up all of the space? I guess we have a couple of versions of the Z compiler we can get rid of. Okay. This is really concerning. Why is there like... Okay, let's get rid of these versions of the Z compiler. Oh, come on, I don't want to like recycle this. Just delete it. Come on. Okay, yeah, like all of this can go. Okay. Here we have like an extra gigabyte to work with. This is really concerning. I think we can just proceed on with the stream as usual, but this is a lot. Some of the Z cache files might actually be taking up a lot of space too. We can delete those. Yeah, there's like 1/3 of a gig right there. What's Visual Studio 2000? Wait, really? Like how? I think it's really that. No, that's only a gig. Okay. We still have got a number of zigs. We want zig 13. Nothing in that. We can get rid of these. Okay, that's at least another half gig. Okay, back to actual programming. So we have this animating tile. We also want like animation direction, which we could just, what was this? Was like tile movement direction. We'll just make this undefined at the moment. And then I think we want to keep track of when like the start animation timestamp, just so we can calculate how far we're through any particular animation. Okay, I think hopefully, I feel like we shouldn't really need any, like that should be the only data we need, but we'll see. Okay, save this A for animation. So when we do the update state, this is where we want to compute the position of the tiles. But I guess we're not really, we're actually doing this in the render. Okay. Yeah, if we're not saving the positions of the tiles, since we can determine them from the number, we'll just do it in the render. Okay, so in the draw grid geometry, I think here we'll want to skip the tile if it's also the animating tile. Or tile equals animating tile. And then we'll need to draw this in separately. Draw the animating tile. Ooh, well, hang on. Let's just see. If nothing's animating, the animating tile number we're going to set to 0 anyway. So we can actually just set it like this. If non-zero. So we can say if animating tile is not equal to 0, I'm thinking, before we even start moving stuff around, I'm kind of tempted to just draw this animating tile with a debug color, and then we can actually start moving it properly. But I kind of want to just build the code infrastructure around this first. So yeah, so if the animating tile is non-zero, we can just we'll need to search through the grid and just find out where it is. Again, I'm kind of annoyed that there's no really simple search function. The one again, it doesn't take that long to do it in Zig anyway. But I'm kind of annoyed that it's 7 lines of code when it should just be 1 line. Let's just make something called find tile index. Let me just replace it later if need be. Find tile index. So that we just want this to take in a tile and then return the index. So we can simply say for in the grid, wanted tile. In the grid, searching for the tiles. If if the tile is equal to the wanted tile, then simply return the eye. And if all of this fails, we will return null. And that's it. So all of this, we can instead just say empty tile index tilde is equal to find tile index 0, and then immediately try and assert that it's not null and get rid of the optional part of it. So then, when we're doing the render, we want to, if the animating tile is not 0, we want to get animating tile index tilde to like find tile index of the animating tile. And then likewise we'll want to do another cast. We want to make this a U8. In cast tile index tilde reference that. Okay, and now we want to we just want to get the position of this, or the position of where it should be, the final position of where it should be. What was the nomenclature we used earlier? Was it just like xpos? I guess we're using this like grid coord. So we can say animating a grid coord is equal to grid coord the animating tile index quotiented by the grid dimension, and then the index divided by the grid dimension. And then we'll want to just draw the color there. I'm like saying up here this stuff is like X val and Y val, but I feel like we should be consistent. Or like coords is equal to grid coord this for that, and then here we can just say 40 times coords.x coords.y, or maybe just coord is fine. Oh no, the spammers are back. So much spamming. Is this like the create? No, I want the dashboard. Where's the channel dashboard? Lock these fools. No, oh, it's Twitch, come on. Where is it? Lock. So where were we? Yeah, we want to draw this thing. So let's just draw it at the moment with like a debug color. We won't do any of the position yet. Calculate the animating position. But yeah, we'll just draw it in the usual way. So I guess have we already stored it in the grid tile rectangles? Yeah, we have. Oh, I see. The reason we needed to calculate this is that we just wanted we wanted like the raw positions, not like the vec2 positions. But I think if we're drawing this, we can just use the vec2 positions that we've already stored in the rectangles, right? Rectangle equals, yeah. Actually, this is what we should say as well. Okay, so in that case, we can avoid this. And we can simply say the animating grid coordinate is equal to the grid tile rectangles and then the animating tile index. And then yeah, we just want to calculate. If we say calculate the animation position offset, we'll do that, and then we've got so we'll call it like animated position, and currently we'll just or like, and instead of animating tile coordinates, more like final tile. Final tile coordinate is that. And then the animated tile, it's not coordinate either, it's position. The animated tile position is going to be shifted, but currently we'll call it the final tile position. So then we want to draw it. So we want to just say, well, we kind of want to then update I was going to say update the grid tile rectangles, but we can kind of just construct what it should be. Animating tile rect is equal to the grid. I was going to say like grid tile rectangles. I feel like we should just get a local copy of it. Let me say grid tile. The grid tile rectangle is equal to this. And so the final tile position is just the grid tile. It's more like animating. More like the final tile rect is this thing. the final tile position is just the final tile rect dot position. We get that. So then we do the calculation, get the final, and we get the animating tile position. And then the animating tile rect is going to be a rectangle with position, the animating tile position, and then otherwise, like the height, the width and the height will be the same as the final tile rect height or width and the final tile rect edge. Okay. Then once we've got that, we can then draw the colored rectangle. I'm just thinking, like I'm thinking ahead, we're gonna have to like change the color. This should, since this color is like based on weirdly it's based on like I feel like this should probably be a separate function. We can get around to that. So yeah, draw a color rectangle. So we've got like the inner rect, but you also want the animating tile border rect. And this is going to be a rectangle that's just the the animating tile rect dot pos, and then the tile border rect width, and then the tile border rect both times. Okay. And then we can draw a color rectangle that's the outer border rect, and we want this to be the tile border color. Then we want to draw the inner one, which is the actual animating tile rect. And this one we'll set to be the debug color for the moment. So what this compiles is a different matter, but for the moment, let's just set the animating tile to be like when something moves, we'll just immediately set the animating tile to be that. We won't adjust it for this compilation, but as soon as we start adding in timings, we will. So let's see. So what did I say today? Okay, so if things are moving up, and it's possible to move it, here we want to say we want to say, like, this is telling me even more. We need to factor this code at some stage, but later the animating tile will be well, what isn't it just going to be this? Oh no. The whatever is being something's moving into the empty tile. So it should just be the grid and the empty tile index, and then the animation direction should be in this case, just up. Okay. And then we should just, this stuff factors out, therefore we copy and paste it everywhere. And let's just add in a to-do that we really need to factor this. Okay, let's try and compile this. I'll move it over here. Zoom in. The current build run. Wait, why is it building like GFLW test? Like what? What on earth is happening? It shouldn't be doing that. Should be called sliding puzzle. Let's try again. Undeclared identifier tile movement direction, really? Oh, it's called grid movement direction. Oops. I have to move this over here. 73. 229. Empty tile index. Okay, how does it not? Tilde. Let's try again. Animating tile index 363. Okay, well, where did we compute what the index was? Okay, here, so we simply need to move this down. Things were just slightly out of order. Okay. Animating tile pause. Yeah, because in this case it should be final tile pause. It will be some simple arithmetic equation. 374. Undeclared identifier animating tile pause. Yeah, why is this called like animated? It should be called animated. Okay, finally. Okay. Okay, so things are moving, but there's suddenly no grid at the moment. I guess I really do need if tile is equal to 0 or tile is equal to animating tile. Okay, this is better, much better. This is what I expected. Okay, and then we expect orange, green, and pink to be able to, yeah. Okay, so that is, let's just save that. What did we do? That was it. Yeah, started like, made animating tile debug. Okay. So now let's do this like calculating the position offset. There's going to be even more more code to add to the switch statement. We're going to have to factor out eventually. But before we even do that, we want to save what the timestamp is at the beginning of each frame. So if we go to our main function, I think before we even pull what the events are, we want to save the timestamp. Okay, so we can say here frame timestamp is equal to is equal to the stopwatch dot read. I think that's right. Let's see, we can just check the source. I guess it should really be z current now. Let's see, library standard time.zig. Const timer is equal to this. Yeah, it should just be read. Yeah, reads the timer value since start or last reset in nanoseconds. Yeah, so there we go. Okay, then once we've got that frame timestamp, we can then use that to calculate, we want to save what that is when we recognize that a tile has moved. Oh yeah, but we already did that. This like start animation timestamp. So where's the huge switch? So I know one way we can factor this out. I think. Actually, no. Let's just do it. We want to just set the start animation timestamp to be the frame timestamp. We need to factor this out so bad. I'm just literally copying the same code 4 times. Oh, this animation direction stuff is incorrect though. That's what happens when you copy pasta. That looks better now. Okay, so we've got the start animation time frame. So now when we actually start rendering this, we can we want to calculate the time. So we can do seconds since animation start. Yeah, and I guess we're going to want to call a different function that converts these two timestamps to So let's call this like timestamp delta to seconds, and because we want to do the frame timestamp minus the animation begin. What did I even call it? The start animation timestamp, I don't like this name. It should be called animation start timestamp. Emacs. Okay. So let's write that. Let's write this function. Timestamp delta 2 seconds. So we can have like T2, which is a U64, and a T1 that is U64, and let's just return a float. So let's see, these are representing nanoseconds, so we could say nanosecond difference is just T2 minus T1. Oh, is the compiler gonna yell at us because we're potentially like getting an overflow? We'll see. The time is monotonic, so it should be fine. Let's just say that. Okay, then we want to convert this nanosecond diff into seconds. So we simply want to divide it. Ooh, we don't want to do like a like a walloping division. I think we want to like float it. We want to convert it to a float first. So we'll say like nano diff f32, float from int. We can just do this immediately. T2 minus T1. So then we can just say seconds diff is equal to seconds diff. Do I include the F32 in there? Is it because it's redundant? No. The sex diff is just going to be the nano diff, well, divided by how many nanoseconds there are. So nano should be 10 to the 9. Before I start putting anything on the screen, let's just like print out what this is. Debug sex diff. Sextants animation start. Z current. Okay. Doesn't like it. Why? 255. Start animation. Animation start confirm. Why is it giving us the same? Let's edit all of these. Start animation timestamp with animation start. Okay, this is promising. It looks like, yeah, the seconds are, we're getting the timestamps that we want. Okay. Let's make it full screen again. Yeah, so that's working. We are going to want to clamp this. So let's just say, I think we will want to normalize this as well. Like, let's just add in a number for the animation speed. Oh, that was, I knew I had forgotten something. Animation speed. That's like way too general. Sliding, or like animation sliding tile time. Let's set this to be really slow at the beginning, like 1. So let's set the clamp time to be, how again does the clamp, are the arguments in clamp? So it's the value, then the lower, then the upper. Okay. So the sex, since the animation start 0, and then the animation time sliding tile time, and then we can say animation fraction is equal to the clamp time divided by animation. I feel like the compiler is going to have a whinge. It's like, this is a comp time int, but you're like dealing with floats. When really it's like, can't you just like convert it for me, compiler? That's what Odin does. But only at comp time. But it's okay. We will make do. Okay, so that gives us the clamp time. I suppose at this stage we should even check that before we even do any of this. We should check that the animation hasn't finished. Like, because if it has, we want to be setting the animated tile as like we want to just indicate that nothing is animating anymore. Why do we decide this? Well, we don't want to clamp it for 1. I think clamping this is unnecessary, actually. This is... It doesn't feel correct to be doing this in the render. This should, like, this stuff should be calculated a bit earlier. Why don't we make the animation fraction a global? Let's see, F32 should make it to 0. And then when we do the update state, that's when we can calculate it and set the animation stuff. Dates. Where's the, how do we go to the previous bracket in Emacs? I'm gonna jump here. Yeah, check if, check animation status. Oh, there's like some weird behavior here, which is that if we say like I'm moving like a tile to the left, and it's like in the very right corner, if we press left again, we don't, like nothing's moving, but the pressing the left should cancel the animation. Like it should, but this current logic won't do that. It will just say, oh, will it? You know, it will, because it will break here before we set this info. Maybe we should really be setting the animation start timestamp earlier, like as soon as there's a movement direction. Yeah, I think we should do it here. So we can just say, yeah, if tile movement direction. I know, this isn't. Like, if there's a key press, that's when we need to reset the animation. Yeah, reset animation if key press. I guess the thing is though, if it, like it shouldn't just be breaking in this case. It should also, like it should also be just cancelling the animation to none. We will do this. We will do this up here. So let's bit cast the key press. So if this is not, if the key has been pressed, then we do want to factor out these lines. then, if these things can't move, we also want to set the animating tile to be 0. I'm like almost tempted to factor this now, but let's just move on. Okay. But we also need to again, we also needed to like check if the animation is over. Like we just want to do like a comparison of the animation time, but is this the correct place to do it? And then set the like set the animating time to be 0. And here we just want to say if the second since the animation start is greater than the animation slow time, then we want to say we just say animating tile is equal to 0. Maybe that's going to get overridden by this stuff. I think we just want to say tile movement direction is equal to 0. Well, no, it's the animation direction is equal to 0. Is equal to none, and the animating tile is equal to 0. Okay. Let's okay. So then once we have that, what happens in the render? We then want to say I think part of me is that we haven't like committed to whether to like how we're determining the animation, if it's by examining the animating tile like or the direction. I guess we'll just Provided both are like set together, it should be okay, but I'm feeling slightly iffy about it. Didn't we need to calculate a fraction somewhere anyway? Otherwise, calculate animation fraction. Okay, so otherwise, if the time isn't passed, now this is when we want to do, we just want to say the animation function is equal to the seconds since animation start divided by animation sliding talk time. So now we can use this animation fraction to move the position of the tile. We're gonna have to move it based on the direction, but just to check that things are working to begin with, we'll just have it moving anywhere. Make it move in the proper direction. So we'll just say the animating tile pause is equal to final tile pause plus the animation fraction times, we're gonna have to like splat the vector, animation splat, which is a vec2, split the animation fraction. Okay, then we can say animation splat times whatever the direction. So let's just make it 1, 0 to begin with, but the 1, 0 will be from an enum. Okay, many errors. Let's move it to the side. 403. Come on. Why does it think this is comp time yet? Clearly these are comp time floats. Wait, what? Come on. Okay, maybe I just need to declare this is a vector. Okay. Oh no, and things are not animating. Oh, actually, they kind of are. They're just moving so slowly that we're not noticing that. Okay, let's make it like 100 then. Like, they moved by a pixel, which makes sense. Great. Tiles are animating. Not in the right direction, since we're going to fix that, but they are taking about a second to move. Okay, cool. So let's now move it which way? Which direction should it be in? Keep it like this. animation slide. Okay, so let's now change the sliding tile time to something a bit quicker, like 0.3. And then let's do the direction. So this vec 100 here should be, would you say like animation offset vector is a switch, and we'll switch on the animation direction. Let's see, if it's none, we should get an unreachable. But otherwise, if it's up, we can back to. If we get the if we get the orientations wrong, it'll be really easy to fix. So let's make this. Oh, hang on. We need to know the exact distance if we're going to be doing this. So the exact distance it needs. The exact distance it needs to move is a bit of a calculation. So you can say like animation distance is going to equal the grid. So many constants. All of these things. So it's going to be the tile width plus 2 times the tile border width plus the grid border, plus tile spacing. Okay, and then once we've got the animation distance, let's say if we're going up, we've got that, and then I just want a quick abbreviation, call it like AD is equal to animation distance. So if it's up, let's say we then want it to move like 0 AD. If it's left, then so AD 0. If it's down, 0 AD, and then one of these should be negative. Some of these should be negative. Okay. The S symbol on my keyboard. Because the S is dash in Dvorak. Right. AD 0. Okay. And then that's the animation offset vect. So then over here we want to be multiplying this by the animation offset. Okay. Let's try and see how this works. Okay. The animation speed is too fast at the moment. Let's turn it back from 0.5 to 0.3 to like 2. Something really slow, so we can see how the animations are working. Okay. So I think for one, I think these things are going, yeah, these are going in the wrong directions. Oh, hang on, they are actually going in the right direction. It's just the offset is the offset's really wrong. Oh, right. Since the grid has already, since the tile has already moved to its correct position, we need to we want to reverse the direction and reverse the animation fraction at the same time. Okay. Where's the switch? Okay. So let's invert all of these. And we then want to change the animation splat here from the animation fraction to 1 minus it. Okay, great. Now the tiles are animating in the way that we want them to. Look at that. Super slow. But they're moving. They are moving. Okay, so let's make them faster, and let's also change the debug color. So currently we're determining these colors by this function here. This should be an inline function. So let's call this like, let's save it. Call this like tile to color. Tile to color. Tile is EU8, and we're returning a color. And the color is given by return is given by this. Okay. So once we've got that, we can then do tile to color on instead of debug. Animating tile color is equal tile to color animating tile, and then we'll put in the animating tile color here. Oh dear. 384. Okay, I guess we need to put the grid coord down here. Oh, we forgot to adjust the time, but the colors are correct. Was it 2? Yeah, so let's try like 0.3 seemed really fast when I wanted just to check if the animations were correct. But maybe it's fine now. Yeah, like I think this is it feels a bit too slow actually. At least for my liking. Aha, and notice here that like if I like press down twice, it like, even though like no movement can happen, it does snap it. Okay. I'm kind of surprised that there's not some other weird like animation issue going on, but that was like the order of the animation. Okay, otherwise this is working. So let's make it slightly faster. Let's try 0.2. And then we'll save this, and see, 0.2 still feels a bit sluggish. Like it still feels a bit too slow. Maybe 1.5. This feels, yeah, this feels good. Yeah, this feels good. So I feel like the limit to which people can press the keyboard is, a lot of people can press the keyboard is like around 6 anyway, at least if they're like not super consciously trying hard to like make it as fast as possible. So this, even if I press like 2 in quick succession, it feels like they move correctly. This is good. Okay, great. So let's see. Yeah, we did all of that. Git add. We say git commit. Got grid tiles animating correctly. We should push this to GitHub. And yeah, I think I will call it a night here. How long have we been? Oh, it's nearly midnight. I should get to bed. Yeah, thanks everyone who, well, actually it's not. For everyone who participated in the chat, 100% of chat participators were spammers, so screw you, you're an asshole if you pasted in chat. But to everyone who watched the stream without spamming the chat, thank you for stopping by. Yeah, I hope you learned something this evening. And yeah, like as always, everything that I do, basically everything that I do, is on GitHub. So you can just see all of this code that I modified minutes ago. Weirdly, it's okay. You have to like. Oh, this is ridiculous. Like it's not here in like. How do I? Where's like the more button? Like, it's here, but it's not in these. Okay. You have to go to repositories. And then you can do sliding puzzle in Zig. All of the code is here. Stuff that we just modified. We should remove this GLW test. It's a bit. Let's just clean up the local repo now. Git clean xn. Yeah, look at all of these crappy files that Emacs artifacts. Delete all of those. But we also want to remove this glfw test. Git remove glfw test. Okay. Okay. Now it's not here because we just pushed it. Yeah. How long are we getting in terms of file size? Will GitHub even tell it? Okay. We'll see if we can keep this game under 1,000 lines. Like that would be good. What's happening? No, I don't want all of your simple stuff, please. Yeah, we'll definitely have to massively clean this up. Yeah, but Also, I'm uncomfortable by the fact that I don't know what this random number generator is doing. I think next time it would be good to eliminate this and instead just, and likewise for the actual shuffle algorithm, don't know how this is happening either. I think it would be good to learn, because it's been a very long time since I've had to implement any shuffle algorithm. Actually learn what that is, implement it in Zig, and probably in the process we'll be able to get rid of the pseudo random number generator. We can just hopefully we can just immediately use the timestamp, or some bits of the well, we'll do something fun with the timestamp and then get something somewhat random out of that, and then do our own random shuffle. But yeah, I guess what else? There's notifications. Oh, there's more comments on this little triangle. Oh, it's been fixed. Great. Very good. Might give this a go sometime. But yeah, otherwise, thanks to everyone who stopped by. I should really be getting to bed. And I'll see some of you next time. Bye.